I'm Michele, I'm a front-end engineer at Facebook. I wrote a book about React. I organized a meetup in London, so if you ever come to London, join our meetup. And follow me on Twitter if you want to hear more about me. For the next 30 minutes, I'm going to talk about testing. And yeah, I was about to ask the same question. So how many of you love testing? And I would expect everyone, don't even raise your hand, everyone should love testing. But the second question is, how many of you usually write tests when they write code? Okay. How many of you think that they have the right amount of tests in their code base right now? Perfect. This always works. So basically, there is a huge gap between people that think tests are useful and people that actually write tests. And this talk is about figuring out why this gap exists and see if there are some solutions. And yes, there are solutions. Let's start with this tweet from Aaron Abramov. He works at Facebook as well and is a maintainer of Jest. He says, said this thing I hear from engineers. We aren't writing tests right now because we're focusing on building features. Maybe some of you can relate to this. And I don't want to enter the argument if you should write tests, if you shouldn't. That's up to you. But the point here is that if engineers think that tests are slowing them down while they are building features, then we have a huge problem because it should be the opposite. Tests should make you faster. And maybe the reason why developers think that tests are slowing them down is because testing is pretty hard. And now I'm going to give you 3 reasons why I believe testing is hard. Testing is time-consuming. So if you write proper tests, then you spend more time writing tests than writing code. Which is not bad in principle, it's fine, but developers tend to feel less productive if they don't push code to production. If you just spend days writing tests, you feel like you didn't do anything. Tests are complex to set up. So for example, if you want to test a client-side application and you use, for example, Webpack to create your bundle, and you import any non-JavaScript dependency, for example, the CSS, then running the tests in a node environment is not easy. And finally, tests give you a lot of false negatives. And if you ever wrote an end-to-end test, you know what I mean. Sometimes you have your application working in the browser, you try it, it works, and you try to write a test for it, and the test fails. Because, I don't know, an HTTP request fails, like you try to access a DOM property that doesn't exist in the DOM yet. Like there are so many reasons that can make our test fail, and this is very frustrating. If we all agree, we can call it testing fatigue on Twitter from now on. However, testing is really important. And I'm going to give you a few reasons why I think testing is important. If you might find my next 3 slides a little bit obvious, and if that's the case, it means you write tests. But since there is this gap between people that love testing and people that write tests, then it's good to iterate one more time on these concepts. Tests can help you catching bugs. You knew that? If you test your function, you can make sure at least the function does what it's expected to do, at least in the happy path. And also, when you have a test written for a function, then it's easier for you to spot the edge cases. For example, you can pass null or 0 or whatever to your function. Tests can give you confidence to you and to your reviewers as well. So if you put a PR, and it's baked by tests, then your reviewers are going to be more likely to accept it because tests guarantee that at least something is working as expected. And if you work on a huge legacy code base and it's covered by tests, then you can concentrate on the new feature that you're working on, because if you don't worry about breaking anything else, because tests are going to tell you. So this gives you a lot of confidence. Finally, I'm not a huge fan of documentation, of written documentation like READMEs and wikis, because it gets outdated very, very quickly. But if you use tests as your documentation, then they must be up to date, because if you update your code and you don't update your tests, then tests are failing. So the tests tell the truth. And when I find a cool repo on GitHub, I usually go straight to the test folder and I read the test, because tests are telling me what the module, the package, the function is doing. Cool. It's fair to say that the way engineers are approaching testing is changing over time. And here are a few examples. This is a tweet from Dan Abramov. He works at Facebook in the React team, and he says, unpopular opinion, component unit testing is overrated. And I was disappointed when I've seen this tweet, because I used to do run-driven development for a long time, as many of you, I guess. But I see his point. He says components should be very simple. They change very often, so they should be flexible. And unit testing is not the right solution for that. And there are better solutions, and we will see one later. Guglielmo Roach from Zehid, they're doing super cool stuff with JavaScript. You should follow him. He says, write tests, not too many, mostly integration. So again, unit testing is losing its appeal year after year. In fact, if we go back in 2009, this is like the old pyramid of testing, and was saying, you unit test all of your code because it's cheap. Then you test a few services because testing are more reliable but more expensive to run and to write. And then you do UI testing to make sure your application works. And in 2016, Aaron Abramov proposed a new pyramid of testing, which I really believe is the way to go now. He says, you cover all of your application with static analysis. So tools like Flow, for example, can help you making sure you receive, your functions receive the right parameters. Tools like ESLint can help you making sure, for example, you don't access undefined variables. And then you write a few JavaScript tests, and you don't care anymore about unit testing, integration testing, functional testing, whatever. You should concentrate on the value that the test provides to your code base. And you're not going to get rid of WebDriver end-to-end tests. Cool. One tool that I strongly believe is solving most of the issue we have seen until now is Jest. And it has been built with the developer experience in mind. And it tries to make testing a delightful experience. And it's one of my favorites right now. And I'm gonna tell you why. It's a zero configuration platform. So you just install it, you run it. For most of the use case, you don't waste your time writing huge configuration files. It's fast because it runs tests in parallels, but it's also tests are sandbox, so they don't leak the state to each other. And this is my favorite one. It gives you an instant feedback. So if you run just in the watch mode, it keeps on listening, and as soon as you save a file, it's smart enough to figure out which tests are affected by those file changes. And it runs the test for them. And if you have, for example, 1,000 green tests and then you have a red one, the next time you run Jest runs the red one first. So it runs the failing test first. So you don't have to wait for the 1,000 green to run again. This, in conjunction with the bail option, which stops Jest as soon as one test fails, it gives you the fastest feedback loop. So you don't waste your time green, 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 and then red in the end say, oh, shit. It has built-in coverage reports, a powerful mocking library. It's basically a complete product. If you compare it with Mocha, for example, which is a great tool, but then you have to install different packages, like Chai for expectation, Sinon for stub and mocks, and Istanbul for code coverage, and JS DOM if you need a fake DOM environment. You have to install additional packages, which is okay, but also you have to keep these additional packages up to date, and this is the most annoying part. It works with TypeScript and with any compiled to JavaScript languages. Cool. If you were to ask me one single reason to use Jest, I would say that's snapshot testing. I really, really, really love it. And how does it work? So when you run Jest for the first time, Jest takes a picture of the output of your function or the output of your components, and it stores. And then you make changes, you add a new parameter to your function, you change the implementation, whatever, you run Jest again, and Jest takes another picture, we will see later it's not actually a picture, and it compares the two. And it can tell you if something is changed in the output. It doesn't tell you if you did something right or wrong, as many other tests. It just tells you something is changing the output. Do something about it. And I'm going to show you an example. How many of you have no idea what React is? Fantastic. We are friends. Um, so this is a React component. You don't need to know React to follow my talk, but I'm going to use React as an example. So it's better if you have at least an idea that with React you can create components. And this is a button. It's a UI component. And a React component is actually a function. It takes some parameter called props. And this component is a button that takes 3 props: disabled, primary, and text. And the class name of this button is going to be primary, or either primary or secondary, according to the value of the primary props. And then the disable attribute is going to be true or false according to the disable, and then you pass the test of the button. This is a super simple button. If you were to test it with Enzyme is a tool that you use to test React components. It's just a set of test utilities, nothing more than that. You can render the component into a wrapper. You can shallow render it, which means you render your tree of components only 1 level deep. And then you can write some expectations. For example, we check that disabled property is true. Then we check that the primary class has been applied as expected. And then we check that the text of the button is the text that we provide as a prop. Simple, it works, it has no problem. But if you think about that, this is a super simple button with 3 properties. And this one test for only one combination of these properties. If you had to write all the combination for the different properties for a more complex component with, say, I don't know, 10 properties, then you would spend more time writing tests than writing the code, and which is not the best. And also, if you would change one property, for example, you would have multiple tests failing, which, again, is not the best. And here is where snapshot testing comes to rescue. So you have only one expectation. You use the React test renderer, which is a different renderer. Basically, it's a way to take a React component and transform it into a serializable JSON object. That's it. And you say, I expect these 3 to match the snapshot. That is it. And the snapshot looks like this. So it's not a picture, as I said before. It's a text file. And actually, you can see here, this is a human-readable output of your component. So you have the button, you have the class name, which is primary, you have the disable attribute that is true, and the text of the button, which is click me. And this is super easy also. It's super useful in code reviews as well, because you receive the test and the snapshot, and you can check by yourself that the output is right. But what's the power of snapshots? So suppose we want to change our class name from btn to button primary, because we change the way we name our classes. If you would do that and you would save your component, then Jest would tell you something like this. It would tell you, hey, the class was button before, sorry, it was btn before, it's now button. Are you okay? Like, is it a change that you wanted to do, or like, did you do it by mistake? And this is awesome, because if you did it by mistake, you go back, you fix the issue. But if you are happy with the change, Jest presents you a list of actions that you can take, which the second one being update. So if you press U, then you update your snapshot, and then the snapshot will contain the button class, the last class that you decided. So this, for me, is the best developer experience, because you run Jest, it takes the snapshots, you work on your components, just tells you what's changed. If you are happy with the changes, you press U, that's it. If you are not happy, obviously, you fix the bug. And that's it. This is the best developer experience you can imagine to test React components or the output of the functions. There are some common misconceptions around the snapshot testing, and I want to give you the answers right now, so as soon as this talk is finished, you can migrate to Jest with no doubt about it. First of all, a question that I got asked a lot of time. Should I commit my snapshots? Of course you should, because snapshots should follow the life cycles of your component. And snapshots are not only useful for yourself, but also for your colleagues. So for example, if I commit this button, I commit the snapshots as well. So if a colleague of mine is going to change the class name, they want to know if something is changed. And if I change this component again in 6 months' time, I still want to know if something is changed. So you should absolutely commit your snapshot. How is it different from visual regression testing? Because it's a tool for testing UI, so someone would say, Why is it different from visual regression testing? Why is it better? Why is it worse? It's completely different because visual regression testing usually takes screenshots of your UI components and then it compares the pictures pixel by pixel. So even if a small thing changed, your test fails. They're usually flaky and very sensible to any kind of change. And also they are pretty slow because they compare pictures. While snapshot testing uses text files. So it's super easy to compare, and also they are pretty easy to merge if you have any conflict. Last but not least, does it work only with React component? This is a common misconception because a lot of people think, okay, the snapshot testing is only for React components. Absolutely not. You can test with snapshot any serializable value. So for example, if you have a function that returns a JSON object, instead of like what you usually do, you console log the output of the function, you copy the JSON object in your test, and then you iterate on it as soon as this object changes, right? With snapshot testing, you just create a snapshot of the output, and if you add new properties, Jest is going to tell you, that's okay, yes. And for example, the output of Jest is tested with snapshot testing. So the output that you see in a console, it's a perfect use case for snapshot testing as well. Cool. The second reason why I love Jest is because you can easily customize it to fit your project, your application, and to better solve your own solution. And this is a solution I personally built to test the style components. And if you don't know what they are, you're going to see one very, very soon. But this is just an example to show you, okay, snapshot testing provides a great value to you. But if you need more, you can easily customize it and change the way snapshots are generated. This is a style. How many of you have no idea what style components are? Okay. But if you come to me later, I can tell you more. But it's a very simple way. It's the coolest ways for me to add styles to React components. It's what's called CSS in JS thing. And basically, this is a super simple example. You don't need to know style components very well to follow this example. But basically, you import the style function from the style components, and then you use the button function from the style. The style object, you use the button function. You have utility function for creating buttons, divs, ps, text area, whatever. You have all the elements. And then you pass the styles to it. So for example, color blue, the actual CSS. And what is going to happen here is going to render a button in the browser, and then it's going to put the styles in the head as well, and it's going to add a class name to. Hello? Oh no. Okay. It's going to add the class name to the button and add the style to the page. That's it. So this is a way to create style components, as the name says. And if you create a snapshot of a style components, however, you would see something like this. You would see a button with a class name. Because what style component does is create a class, it applies it to the document, and it adds the class name to your button. This is magic, but you didn't write any class name. So the first time you see a snapshot of a style component, you say, hey, what did I do wrong? Like, why there is a class name there? And it's not very useful. However, Just can answer the question, did my component change? Because if you change, for example, a button to be a div, then Jess is going to tell you, wait a second, you changed the element that you are rendering. Are you okay with that? Which is okay. It's one thing we want to do. But when we work with style components, however, we want to know if the styles are changing because we are working with style, right? And Jess can partially tell you if your styles are changed, because every time you change your style components recalculate the class name. The class name was basically the hash of the styles. So every time you change the style, the class name changes. And Jess can tell you this, but when you change a lot of styles of different components, you have basically a lot of noise in the console, like of class names changes, and you cannot easily tell if the changes are correct or not. You can just say, okay, my styles are changed. I knew that because I changed them. But the question we want to answer is, how did my style change? And this is why I built this library called JazzStyle component. You just import it, and it changes the way Jest serializes your component. So you can write your own serializer that receive the JSON object, the tree of components, or the output of the function, and you can do whatever you want with it before the text file, the snapshot text file, is generated. In my case, what I wanted to do was to add the style to the snapshot as well. So as soon as you change the style, Jest can tell me that actually the style is changed. And also, I created some placeholder for the class name because they were noisy and they didn't have any value to the snapshot. So you would now have C0, C1, like it's the index of the style in the page. So now, adding my library, your snapshot would look like this, which is way better than before. And if you change the color, for example, from blue to red, then yes, Jess can tell you now your style is changed in this way. So you are actually testing styles as well with your test framework, which is awesome, which is not something that we usually do. At least I didn't used to do it before. Cool. So if I convince you, follow FBJest, start FBJest, migrate to FBJest, to Jest. Basically, you can use a code mod, which is a very useful tool that takes your source code and it changes, it applies all the transformation, for example, to migrate from Mocha, Ava, or Jasmine to Jest. So it changes all the test statement, so it works with Jest. You commit it, it's done, it works. Cool. I have Jest stickers as well later, so come to me. So if you have any question, I'm going to give you a sticker. What's next? What's next? We have seen how Jest is a super cool tool which solves most of the problems, and I really love it, as you can tell. And what's next? What can we do more? I've seen that the easier you make for developers to write tests, the more tests they write. So I said I want to find more easy way to write tests. So they're going to write a lot of tests. And I came to a conclusion. The best testing strategy is not writing tests, which needs to be explained. I'm not saying not having your code base covered by tests. I'm just saying you shouldn't write any tests. If you don't write tests, you're happy, right? But you have your application covered by tests, and we will see in a minute what I mean by that. Even though this is true, because you can't have failing tests if you don't write tests, but I don't mean this. I built a couple of tools that can show you like what I mean and where I like the area that I'm exploring to see how I can avoid writing tests. And the first one is called the Snap Guidist, which is basically it starts from a simple point. You have your style guide, and if you don't have it, you should, because it's a great way to share a collection of components with the other members of the teams. For example, designers, front-enders, back-enders. You have this collection of components. For example, this is how a super simple button would look in your style guide. You would have the different states that the button can have. So button primary, button secondary, button disable. These are the 3 states. And in your style guide, you usually render your components in the different state that they can have. So you can easily say, okay, this is the primary, this is the secondary color, okay, perfect. But if you have to write tests for this button, you would do something like this. You would test button primary renders correctly, button secondary renders correctly, and button disable renders correctly. And when you do the same thing twice and you have a laptop in front of you, you're doing something wrong, because you can ask the laptop to do the work for you, right? To create my style guide, I use React Style Guidist. It's a great tool. You just define the different states, for example, primary, secondary, disable in a README file. And obviously, it works with React component, as the name tells. And you just define your different states in a README file, and React Style Guidist is going to create a style guide for you. You just define the states in the README, and you have a style guide for free. We will see one in a second. What my tool does, Snap Guidist, it adds snapshot testing to your style guide. But let's see a quick demo. Okay, so this is a style guide generated with this is a style guide generated with React Style Guidist. It's the basic example on the repo, and you have the basic button, for example. You have the big pink button. You have the different colors of the button, for example. You have the counter button. You can even click it. It's super cool because you can generate a style guide that actually that works in the browser. So as, for example, the counter button. But there is this component which is called placeholder, which accepts a type, one of animal, bacon, bird, and beer, and I forgot to tell you one thing. There is a green line below the component, which means that the snapshot has been generated and it matches the current state of the component. So if you can also see the code in style guides, which is also great. And there is this green line, which is what snap guides has to add to React style guides, and it's green. Your tests are green now. Let's change from beard to bear. You should see a bear, yes. And also, you should see that the green line is now red. And you can also expand it and see what actually changed in your source code, what actually changed. And if you are happy with the change, the same way you would press U in your console, you can update your snapshot to have a bear instead of the beard. That's it. And this is actually generating real snapshot files that you can commit. So, and you didn't write any test. You have all of your components on the different states from your style guide tested with snapshot testing. And you do it only in the UI. I didn't write any tests. I have all my tests. This is what I mean. And this is one example. The second example is React Fixit. And again, it's based on React, but you can write your own in your own framework. And again, I started from a simple point where I was saying when a customer or a user tells you that there is a bug in your application, what you usually do, you open your browser, you try to do the same steps that the user take and to make sure that the application fails for you. And so you try to reproduce basically the issue. Why are you reproducing the issue? Because you want to collect all the information, for example, the component that failed, your Redux application state, the function that failed, the parameters, like all the state of the application in that moment when the exception has been thrown or something happened. Then what you should do, what I usually do, you go in your test environment and you use all the information you collected from the browser to write your test. So you want to have a failing test that covers the failing case in the browser. If you have a failing test, then you try to fix the bug and you celebrate. This is it. But again, we are doing the same thing twice. We are reproducing the issue in the browser. We are reproducing the issue in our test environment. And I was wondering, who has all the information I need to write my actual failing test? The browser. So why can't the browser write the test for me? And I'm going to show you what I mean. So this is our application. It's the default application from the Create React App tool, which is a tool to quickly generate a React application. We have one test, it's green, we are happy. We go in a browser, and there is this application, which has a huge bomb. When you click on the bomb, the application throws an exception. That's what the button does. But since there is my tool called React Fixit, listening for these kind of things, you will see more than just an exception. So I click the button, it explodes, it throws a poop emoji, but also it gives you the test snippet. Because the browser knows the component that failed, it knows the parameter, it knows everything you need to write the test. So if you just copy the test here, you open your editor, you add the test here. This is basically the failing test. You save it. Yeah, the app should not throw a poop emoji on component will update, right? You go back to your test, and you have one failing test. Yes, so we have a failing test. We didn't write any test. We are super happy we now have the test. Now we have to fix the code. And what I usually do to fix my code, I just delete some lines. It always works. And it's going to work this time as well. In fact, if we remove the lines that actually throw the exception, then the test, let me just refresh here, the tests are green again. So we had one test, we now have two tests. We didn't write any tests, yes. Cool. Let me go back to the slides. Perfect. A super quick recap and then questions. First of all, find the painless way to write tests. So if you don't write tests because writing tests is hard, because it's time-consuming, because it's not a delightful experience, then you should not stop writing tests. You should just find the right way of writing tests. So for example, I customized Jest to test the style components to make it easier my life, and other developers' life too, to test the style components. So find your way, like spend time, invest time in finding the best way for you and for your team that makes everyone happy when they write tests. Write more tests, because this was like our point, right? You should go away from me and write a lot of tests this evening. And most important, have fun, because writing tests should be fun. And it is fun, as you have seen. I mean, at least for me, it was fun writing these tools and having these tests for free, and I could do something else, something that would make me feel more productive. And if your application is covered by tests, you can even ship to production on 5 p.m. on a Friday and enjoy your weekend, which is awesome as well. I'm not saying you should do that, but if your tests are green. Cool, so if you have any question, please ask me questions now, later. I've got Jest stickers, and ask me questions on Twitter, whatever you want. I will be very, very, very happy to talk to you about Jest, React style components, anything, JavaScript. Thank you very much.
Thank you. So, hands up now, who loves testing?
Come on.
Excellent. So, make him happy, and after 3, everybody
even
shout,
even if it's not
I
true,
love testing. Okay? I love testing. 1, 2, 3.
I love testing.
Mad.
That was cool.
Mad people. Lots of questions. You have Jest stickers, and,
yeah.
that makes you Mr. Jest. So, many Jest questions. As usual, I'm going to start on the easy questions and then work up to one which is going to fuck you.
Uh-oh.
Okay. Can I say fuck you? Is that okay?
Oops.
Gabby, can I say fuck on the stage? Gabby, can I say fuck on the stage? Okay, thank you. Jest only supports the old Node debugging protocol. How's the debugging experience at Facebook?
Okay, I didn't even know about that.
Mr. Jest.
Yeah, no, but the reason is, why do you want to debug Jest? I mean, it works. You write your test, it works. You don't need to debug it. So, yeah, whoever asked this question, we can talk about it.
I didn't ask it, but what if it doesn't work?
It works. I can assure it works. I see. No. Obviously, I was joking. I usually don't use the node debugger, so I'm sorry. I can find information later, but I usually don't use the node debugger. I check the output of the function, for example, things like this.
Whoever asked the question, did that answer it?
If you want, I'm super happy to talk about it later. I want to learn more about that.
No, well, we'll do it now. We'll put him on the spot.
Oh.
Test. Yeah,
Test.
so we encountered a lot of situations where we needed to debug, and I guess my general question was, how do you guys do it at Facebook? Because I suspected that you do need to debug a lot.
But to be honest, like we use just as any other person would do. We don't do anything special. So I can tell you more later. I mean, if anyone is interested. But yeah, I usually don't use the node debugger myself. So I'm sorry.
Quick question: does Jest ignore white space changes?
Jest no, it doesn't. But this is a good thing, because, for example, if you are, I don't know, if you are testing the output of your console and you add like white spaces, like you want to know that. So it doesn't, but for a good reason.
And does Jest measure code coverage?
Oh yes, this is a great question. Sometimes some people ask me, like, how do I reach the 100% coverage with snapshots. Like it works the same way as any other test matcher that you use, for example, to equal to like all the other matchers, you know, to have length, to equal, to be, because it just checks that when you run your code, for example, when you run your component or your function, it just checks that you pass through that branch of the function. So it works as any other. So you just add -- coverage when you run just on your console, and then you would have the coverage report, which is also pretty cool. In HTML, you can even click on each file and see which parts of the code are covered, and it's pretty cool. But yeah, it does work.
Excellent. Question from Felix, our first speaker. Any advice on testing performance, e.g. function execution speed across browsers?
Oh, this is interesting, but yeah, across browser. Just uses JS DOM, so it uses a fake DOM, and this is where this is basically the domain of JS is actually using this fake browser implementation, which is okay in most of the case. I didn't find any issue, like for example, testing something with JS DOM that then would have worked in the browser because of different APIs. So going back to your question to test performance, I don't use tools like Jest to test performance. I mean, you can use a different set of tools. But yeah, I wouldn't use like this kind of like Jest, Mocha, or Eva to test the performance on the browser, actually. It's a completely different domain. I'm not sure if I mean, just to tell you how, I don't actually do it, so I'm not sure, but I wouldn't use a tool like this. But we can talk later again, because it's going to take longer. I want to know more about the question, actually.
Excellent. And the hardest question of all, this is from Clara, who's from Spain. Who makes the best olive oil, Spain or Italy?
Oh my God.
Answer the question.
Oh, yeah. I would obviously say Italy, but also the Spanish one is very good.
What a diplomat. There's a career for you at the United Nations if this Facebook startup doesn't take off. And the last question from Matey. Where are the stickers?
Oh, yeah, they are there. And yeah, please come to me. I'm going to give you the stickers.
Excellent. Thank you very much.
Thank you.